Hi everyone, this is Mrs. Eggerding again, and you're watching Unit 4 Video 9, and we're going to introduce solving equations that have radicals in them. Now before we get into some actual examples, we want to make sure you understand what we mean by inverses and undoing. And you may remember from Algebra 1 that if I had something like the square root of 6, and I wanted to undo that square root, I could take the square root of 6 squared, and it would leave me with 6. So this undoing is what we call the inverse. So the inverse of a square root is going to be squared. So now we can extend that to our cube roots. Say it's the cube root of 7. To undo that, we take the cube root of 7 cubed. And so our inverse is here, cube root of 7 cubed leaves us with 7. Now how does that work so nicely? Well, we can use what we know about exponents. We know 7, cube root of 7 is the same thing as 7 to the 1/3 power. When I raise it to the third, exponent properties say I multiply those exponents, I end up with 7 to the 1st power. Okay. If I had 15 to the 1/4 power, to undo that, I have 15 to the 1/4. What's going to give me an exponent of 1? We'll raise it to the 4th. I multiply those two exponents, and I'm left with 15. And so this undoing of square root squared, cube root cubed, 4th root 4th, that's what we're going to use to solve our equations. So the first couple I'm going to do are going to be square root equations. And the first one says x equals square root 3x plus 18. I have a square root I need to undo, so I am going to square both sides. The left side gets me x squared. The right side, I have the square root of 3x plus 18 squared. My square root and squares are inverses, so they're going to cancel out, leaving me with 3x plus 18. What's left now is a quadratic. Quadratics, I need to set equal to 0 and solve this quadratic. This one factors very nicely. X minus 6, x plus 3, and it gets me two solutions, 6 and negative 3. Now the only thing, because you're all excited, yay, I'm done, the only thing you do have to be careful about here is this guy up front. My original problem has a domain restriction. It has domain issues. So we do have to check for extraneous solutions. Okay? Make sure you check the solutions. If I plug the 6 back in here, I get 6 equals the square root of 3 times 6 plus 18. That's 3 times 6 is 18. 18 plus 18 is the square root of 36. And 6 does equal square root of 36. So that one's good. The second solution says negative 3 equals the square root of 3 times negative 3 plus 18. 3 times negative 3 is 9. Negative 9 plus 18 is 9. The square root of 9 does not equal negative 3. It equals a positive 3. That is a problem. So negative 3 is an extraneous solution. Square roots aren't going to equal negative numbers, and so I do only have one solution. You do have to watch out for those. Okay? Let's take a look at the second one. It still is a square root, but it looks a little more complicated. First thing I want to do is I want to isolate my radicals. Isolating the radicals means I'm going to leave the square root of 2x by itself, but I'm going to move the x and the 4 to the other side, and so instead of negative x plus 4, it becomes x minus 4. Now I can go ahead and square both sides. Squaring both sides gets me a plain old 2x, but on the right I have x minus 4 quantity squared. I do have to make sure I multiply that out correctly, and that's going to be x squared minus 8x plus 16. It's a quadratic, so I set it equal to 0, x squared minus 10x plus 16. I can factor, and this is going to factor x minus 8, x minus 2. It gets me two solutions of 8 and 2. Again, make sure you check those solutions. Go back all the way to the beginning. Actually, you can even go to where the radical is isolated. So the square root of 2 times 8, does that equal 8 minus 4? 2 times 8 is 16. Square root of 16 is 4. 8 minus 4 is 4, so that one checks. When I check on the other side, or for x equals 2, I get 2 times 2 equals 2 minus 4. And again, we run into a problem where I have the square root of 4 equals negative 2. In this case, square roots, they do not equal negative numbers. I get an extraneous solution, and my only answer is x equals 8. You're going to find those extraneous solutions pretty often on the radicals. Okay, let's take a look at things that are not square roots. So this first one, I have two sides raised to the 1/3 power. To undo a 1/3 power, raise both sides to the third. So it'll look like 3x plus 7 to the 1/3 cubed. 4x plus 2 to the 1/3 cubed. Raise both sides to the third power. A 1/3 and a 3 multiply to be 1. So I have 3x plus 7 equals, the exponents cancel each other out, 4x plus 2, and it's a linear equation. Subtract 3x from both sides, subtract 2, x equals 5. I should go back and check this solution also. I have 3 times 5 plus 7 to the 1/3. Is that the same as 4 times 5 plus 2 to the 1/3? 3 plus 5 is 15, plus 7 is 22 to the 1/3, which is some nasty decimal. 4 times 5 is 20, plus 2 is 22 to the 1/3, and everything's all good. So we have one solution, 5. And the last one we're going to look at is a fourth root. Again, to undo a fourth root, we are going to raise to the 4th power. So it'll look like the 4th root of x squared plus 6x raised to the 4th power, and 2 raised to the 4th power. The fourth root and the fourth power cancel, so I have x squared plus 6x. X squared plus 6x equals 2 to the fourth power is 2 times 2 is 4, times another 2 is 8, times my fourth 2 is 16. It's a quadratic, so I set it equal to 0. This does factor nicely, x plus 8, x minus 2. It gets me two solutions, negative 8 and 2. You do want to make sure you go back and check. A fourth root is going to have domain issues, just like a square root would. So you want to check a fourth root of negative 8 squared plus 6 times negative 8. That's going to be the fourth root of 64 minus 48. That becomes the fourth root of 16, which is 2. So that's going to check out. Checking the positive 2, you have 2 squared plus 6 times 2. That's the fourth root of 4 plus 12. That's also the fourth root of 16. That checks out. Both numbers check out. I don't have any extraneous solutions. So there you go. After this lesson, you should be able to solve some basic equations with radicals by raising both sides to a power. And you should be able to identify extraneous solutions if any of them exist. The 27 to 33 odd and 49 to 59 odd are a really good sample. In class tomorrow, we are going to extend this idea and have multiple square roots and see what happens with that. Good luck. Send us any questions that you might have, and we'll see you in class.